fortunately have this remarkable mapping system on the Odin, something we call a multi-beam sonar. And this is a really cool piece of equipment. A multi-beam sonar creates many beams of sound all at once across a wide swath. That swath can be 3, 4, 5 kilometers wide. Within that swath, hundreds of individual beams of sound are formed, and we get to measure the depth very accurately inside of each one of those beams.
So you're sweeping over the seafloor and you get a three-dimensional view of the seafloor that is rolling up underneath you. And this is the modern sonars that we have on research vessels today. And it is the state of the art and the way we need actually to get this high resolution information that we can interpret in terms of, for example, the seafloor morphology that is related to glacier movement in the past. The tiny little icebreaker lying there in front of the ice tongue, and you see that from a helicopter, you see how big the fjords are.
Building a multi-beam map is not an instantaneous process. It comes in, the data comes in for a swath, and we build it piece by piece by piece. We would make a pass, we were dodging the icebergs, we'd get a little piece, we'd build it together.
We have brought our small survey vessel, which is called Skidbladner. Skidbladner is a very small little research vessel that we equip with more or less the same equipment in terms of sonar capacity as Odin have, but designed for higher frequencies and shallower water.
We were able, despite the icebergs, despite everything, to map almost the entire fjord. It was fantastic. 95% of the fjord got mapped, and that was beyond our wildest dreams. We were just so excited. And then when we finally got to the glacier end of the fjord, when we see the ice tongue, that's literally a straight wall of ice. That's maybe 10 meters high, which implies that it's another 90 meters down in terms of how thick it is. And at that point, it was like a light bulb going off. Aha! Now we see what's going on. Now we see what's restricting that water.
From the multi-beam mapping, we found in Ryder we have two sills, two very pronounced sills in the fjord. So we have an outer sill at the entrance of the fjord. In there we have a second massive sill, even bigger and much shallower than the one at the fjord entrance. This one is preventing the Atlantic water, or it's not completely preventing, but it's shielding Ryder Glacier from the influx of Atlantic water. So you have a certain depth level over which water has to flow to move into the fjord. So that depth threshold we call a sill.
And that has an impact globally on the rise of sea level. One of the single largest impact of sea level rise right now is the melting of the Greenland ice sheet.
We need to know the shape of the seafloor in order to know how vulnerable these glaciers are for inflowing water.
So you see that we've worked very hard to map these small amounts of the seafloor in the ice here, and we have a lot more to do. And so we're going to work bit by bit to try to cover the seafloor. This is part of a global program called Seabed 2030, a wonderfully ambitious project sponsored by the Nippon Foundation and JEBCO. How can we understand our planet if we don't know what's there? This is what's driven humans forever, is exploration, trying to understand the unknown. And this is what's driving us in our quest to map the entire ocean floor by 2030.